think I just broke my microphone. All right, can you hear me? Yeah. Sounds good. All right, so I'm Peter Sroder. Good afternoon, everyone. We're going to be talking about big data today. So what is big data? Other than overly hyped term, it is when your data set becomes so large you have to start innovating on how you collect, store, analyze, and share it. There's really sort of big challenges in the data. There's three big challenges. One is there's variety, velocity, and there's volume. So many of our customers ask us, do I have enough data to warrant the big data term? For example, is 10 years of stock data is enough data or not? So when we talk about, so volume is the most obvious one. You have a lot of data, that's big data. But velocity is also a really important aspect of big data. So at which speed the data arrives to you, and how often do you have to do stuff with it? Do you have to process it every 5 minutes? Do you have to provide dynamic content to your customers, and you have to understand what they do in real time to provide dynamic content? So how fast is that turnaround really impacts, results in a big data challenge? And variety, there's tremendous amount of data formats, data comes in a structured format, as an unstructured format, and depending on the variety of formats, you also will have big data challenges. Big data is extremely important. It is important because it can provide you with competitive advantage, it can help you understand your customer base better, and it can help you build innovating and interesting products. And bigger is better as far as data is concerned. Even small, pretty naive algorithms over very large data sets could give you a great insight. And it's much better than having a really sophisticated algorithm that you run on a small data set. So the more misspelled words you have collected from your customers, the better spell check you can build. Yelp is using AWS services to regularly process customer-generated data to improve spell check on their website. They also use the suggestions as well, and the suggestions when you provide search terms, you have pre-filled suggestions. They're also based on previous customers that came in and typed those types of queries. So the more customers you have, the more volume of data you process, the more accurate the projections are going to become. The more searches you collect, the better recommendations you can provide for your customers. Yelp is using AWS to deliver features such as hotel and restaurant recommendations, as well as the highlights, review highlights, where I'm sure you all use Yelp, and if you go to search for a restaurant, they give you a top 5 bullet points. What are the good things about that restaurant? What are the not so good things about that restaurant? They don't have editorial staff that goes and selects out of thousands of reviews those bullet points. They actually run it through the language processing algorithm, and they provide those bullet points automatically, and they constantly refresh it as more and more reviews are coming in. So those are innovative products that you can deliver on your customer by looking at what your customers are doing on the website and by analyzing your data. On another example, the more data you have about your customers, and the more data sources you can correlate about your customers, the better advertising models you can build. By incorporating sales data and clickstream data over a long period of time, Razorfish was able to improve return on ad spend for Best Buy by over 500%. So let's talk a little bit about how that happened. So Best Buy is a large website. They have 3.5 billion records, 71 million unique users, unique cookies, and 1.7 million target ads per day. And so the traditional advertising was to look at the clickstream data, to build the advertising model based on what your customers are looking at, and provide the advertising. And typically, you take maybe 4 weeks of that log data, and you build that advertising model. What Razorfish did was they took the wealth of information that the retail part of that business, the brick-and-mortar part, did, and they looked at all the transactions that the customers made, all the purchases they've made, and they correlated, they combined that list with the list of clickstream. By combining those two data sources, they were able to see that a customer, for example, recently purchased a sport movie and now online is looking for a video game. Maybe that's inappropriate to show that customer a sport video game. So that kind of a targeting that was possible to do by combining multiple data sources, and ultimately led to revenue, to more revenue. So big data is growing. It's getting bigger. IDC estimated 2.7 zettabytes of data in the world as of this year, and 40% increase compounded growth rate year over year, which is 7 times of that of overall the communication technology market span. And it's going to grow from $3.2 billion to $16 billion in a few years. It's a really big deal. It's growing rapidly. If you look at another metric, you can see that searches or jobs associated with the big data are growing at a tremendous rate over the searches for the jobs that are associated with the traditional BI, such in data warehousing technologies like Oracle, for example. So that growth we see at Amazon as well. So we look at Amazon S3 growth and the objects that we have on Amazon, and over a short period of time, we really have 1 trillion objects in the store. And you can see that hockey stick is not slowing down. So the data is growing at a really high clip, and what do we do about it? So the challenge of data is how do we collect, store, analyze, and share the data using Amazon Web Services. So let's start with collect. So Amazon provides a series of technologies, some of them you already heard about today, to collect the data. And so things like S3 import-export, where you can ship us physical media. S3 Gateway, we talked about it earlier in earlier presentations, allows you to provide offsite backup, disaster recovery, data mirroring, so you can collect the data on the cloud and aggregate in the cloud. Direct Connect provides an option to physically connect your data center to Amazon public cloud, so you can drive high throughput and low latency feeds into the cloud. And obviously, there's a lot of customers already generating data on the cloud using Amazon Elastic Compute Cloud, for example. So there's also a variety of different open source technologies that people use to stream data from their data centers onto the cloud. So things like Scribe, Flume, Chakwa, those are open source technologies that people deploy to continuously stream data off of their application servers, off of their databases into the cloud. So now we've collecting this data, so where do we store it? So where is your data? The diversity of data storage solution is going to increase over time. And there's really good reason for that. If you look at sort of structure of the data and the data size and the access patterns, you will need to pick up the right solution for your data. So, for example, S3 is great if you have a lot of unstructured data, if you have relatively large object sizes, and so low structure, a lot of data. That's S3. DynamoDB is ideal if you have small objects and you have really high access rate for those objects. So you would want to use DynamoDB if you're building a web application or a mobile application. So you can replace your databases, your traditional databases, with DynamoDB in that case. RDS is ideal if you use essentially very structured schema-like data sets. And the problem with RDS is that it's a single box solution. Of course, you can implement sharding and spread your solution across multiple machines, but that essentially requires development and operations. But RDS is a really useful tool for some classes of data. So depending on what solution you have, what application you have, you will choose a different store, different format for your data. So once you store it in all of those solutions, on premises, in our various different Amazon cloud storage solutions, how do you analyze it? So analyzing may contain a lot of tasks, right, such as organizing, correlating data, validating data, enriching data. For example, you can translate IP addresses in your log data into zip codes. And then from zip codes, you can get rich demographic information about your customer base. So that's a typical task that you do in analyzing it. So we see a lot of customers with data spread across fairly diverse formats and sources. And so imagine if you're a media company and you have maybe a customer sign-up information in a JDBC table, so in a traditional relational data store. And maybe you have some customer purchase history in DynamoDB. And you want to improve your targeting, your content targeting information. So you want to join those sources, those data sets, and then provide that better targeting for your content, and maybe store it in some other data store, maybe RDS in this particular case. And then you'd want to be able to get that store connected to your application, so you automatically feed your application with the latest recommendations. But there's really no reason to stop there. You've got access to a wealth of other data. Maybe you have access to a clickstream data that is located in S3 that can further improve your targeting of your content. Potentially, you have access to third-party applications or third-party data, maybe Twitter data that can have a sentiment analysis about the product that you're talking about. Maybe you want to incorporate that into your presentation, into your content. And so you want to combine all of those data sources. And it's tempting to say that, well, it'd be great if you just put all that data into one data store and then just interacted with that data store. But in practice, it's very, very difficult to do because of all those different formats and all those different access patterns. Not to mention that a third-party data set, you just can't get out of that third party. And so once you've built that really good and excellent recommendation process, right, based on all those different formats, you'd want to actually track your business and see how you did and measure it from previous business that you had before. And so you'd want to have those weekly and monthly operational reports that you want to generate, and then you'd want to store maybe in S3 or some other places. So that is the challenge that typical business would go through that would want to really drive their decisions based on the data. So let's talk about this icon in the middle, that yellow icon in the middle. And that is Amazon Elastic MapReduce. Amazon Elastic MapReduce reduces complexity of cost, complexity and cost of Hadoop management. Hadoop is this data processing framework that we host through Amazon Elastic MapReduce. So you don't have to worry about creating clusters, monitoring clusters, and then tearing clusters down once the job is complete. We integrate Amazon Elastic MapReduce with the rest of AWS services so that you don't have to. So you can just use those other services when you want to pull the data or push the data. And we've done this for a while, so we have unmatched operational experience in this area. So you don't have to invest in system administrators or Hadoop administrators or talent that just maintains those clusters. You can just simply launch a cluster, and then when it's done, tear it down. Product managers can do it. Analysts can do it. You don't have to have dedicated staff for the maintenance. We've been operating the service for over 3 years now, and just over the last 1 year, we've operated over 2 million clusters on behalf of our customers. 2 million clusters. It's a really large number, especially if you kind of think about the diversity of these cluster sizes. We have clusters that are running 1,000 nodes. We have clusters running a few nodes, so it's a really, really diverse segment. Forrester Wave report named EMR the #1 enterprise Hadoop solution because of its integration with various data stores, its ecosystem of vendors that we have on top of Elastic MapReduce, and the number of customers that we have in the service. So let's talk a little bit about Hadoop and big data and why Hadoop is so important. So before Hadoop, data processing looked something like this. If you have a single machine and your data fits in that single box, it's actually pretty easy to manage. However, the moment that the data doesn't fit in that single box anymore, the complexity in building the solution grows exponentially. And so the more data you have, the smarter engineers you have to hire. That was what was before. So only large companies could actually afford to drive that kind of analysis across diverse distributed data problems. Now, Elastic MapReduce lowers the cost of developing and operating a distributed system, and so the graph looks something like this, where you've got more data, fine, just rack more boxes, and I don't know about you guys, but we find it a lot easier to rack boxes and hire smarter engineers. So that's sort of, with that paradigm, we have really sort of a paradigm shift in economics of data processing, where you can, which essentially drives inexpensive experimentation on behalf of our customers. So let's talk about some of the use cases that we see on the platform. We have use cases ranging from digital advertising, which is really big and relevant for this audience. We have web analytics use cases, log processing, and data warehousing. We operate in a really wide number of verticals. Obviously, media advertising is a really big one and very popular. Oil and gas, retail, life sciences. Security has a really interesting case. For example, in the antivirus software companies collect in real time information from all the PCs and laptops and devices, information about how they operate, and they correlate them together to see if any particular laptop might have an intrusion. And based on that information, they build a model that feeds back into antivirus detection software. So there's really a broad range of applications that can be built on top of this platform. But let's talk about sort of a particular use case in the media segment. And the case study here is Netflix. Netflix has more than 25 million streaming members. Their users stream movies and TV shows from TVs, laptops, phones, tablets, resulting in over 50 billion events per day. They use the events associated with all of those streams in S3. And it's over 1 petabyte of data that is stored in S3 for that purpose. Now, data consumed, so the data is processing using Amazon Elastic MapReduce and then streamed back to S3. And so once the data is pre-processed in various different views, various applications can then use that data in those applications. So for example, recommendation engine just pulls the data right from S3 that is pre-processed using Amazon Elastic MapReduce and displays recommendations. If you have further analytics that needs to be done on top of the data, ad hoc analysis can be done using that data in S3 as well. And there's a lot of tools that are available for Netflix when they pre-process their data and put it back in S3. What is interesting is that they have a common, one large Amazon Elastic MapReduce cluster that is always running and processing that data, right? And then they have a variety of query clusters that customers can spin up and conduct their own analytics. So, you know, if I'm a product manager in one team and I want to further drill into some particular problem, I can just go ahead and spin up my cluster. I already have a pre-processed S3 data, and I can query that data using Amazon Elastic MapReduce. Interfaces like SQL or R packages or what have you. Essentially, it's all available to a product manager or an analyst without them having to go and ask permission from their IT department. And so if we look at sort of a particular case where Netflix has a data warehouse, right, where they store event logs from streaming movies, they keep customer dimensional data in that warehouse, and they look at that data continuously to understand their user experience, to improve their user experience. And I want to demonstrate with one example. So one product manager have looked at the data and found that there's a movie, Mega Shark versus Giant Octopus, that all of a sudden became very popular on their network. And the question is why? It's not really an Oscar winner. Why that movie is really popular. Let's pause here. Imagine you're in a traditional data warehousing world and you want to answer that question. What do you have to do? So you have your data warehouse installation, you have your system administrator, and you have to go and ask them, hey, look, I need to load a few terabytes of log data onto our data warehouse so I can run some queries on top of it. And they'll say, well, yeah, fine, that's a few terabytes, so, maybe it's going to be $20,000, $30,000 that we need in capital, and then we can actually allocate that room for you, or maybe a couple of months, and then you can answer that question. Well, guess what? They probably won't go and ask that question. It's probably not enough ROI in this question to go and ask that, right? But in the new model, the product manager just spun up a cluster and started digging into why that movie became so popular. And there was a reason for that. So there is an episode, a 10-second clip in that movie where a giant shark jumps out of the airplane and jumps out of the ocean and bites down the airplane. So what people were doing, they were coming to that movie, skipping to that fragment, watching it, and then going away. I don't know what kind of intelligence the product manager got out of that particular investigation. But the very fact is that you can go and get that investigation and understand your customers in a really deep way can help you drive better products and drive better services. Let's talk about another example where a broadcaster had clickstream data from 500 plus website properties and video on demand platform, and they need to load all of that data and process it. They loaded all of that data into S3 using Amazon import process, AWS import, so they would just ship the disks to us. Then we would load them into S3, and then they would spun up an Amazon Elastic MapReduce cluster and start running those Hive queries, or those SQL-like queries on top of it. It took them 3 days to do that entire operation. So 3 days from shipping to loading to executing and start running clickstream analysis. They were really surprised by this because their original Oracle-based solution, they've tried to do this for 3 months, and they couldn't load this entire data set into that data warehouse. So there's a really big flexibility, agility in how you process your data with Amazon Elastic MapReduce and all of the services around it. You have flexibility to innovate, and the mistakes are cheap. Shut down the cluster if whatever solution you come up with is not working out. And we worry on the back end about how do you tie all of our services together in this analytical solution that is Amazon Elastic MapReduce so that you don't have to worry about it. So for example, we have a seamless integration with S3 where you can just select you essentially can write a query that goes directly against your data in S3. Why S3? Because S3 has 11 nines of durability. S3 is really inexpensive. And if you are done with your cluster, you can just shut it down, and you're not paying for compute. You're just storing data in S3. The other reason, we do a lot of innovation to make it very fast and efficient to retrieve data from S3 and move data back to S3. And so we eliminate complexities around disaster recovery, job contention, because you can run multiple clusters against the same data in S3, etc. So that's a really good mechanism for us to store data in S3 and process it using Amazon Elastic MapReduce. We also do a lot of work to integrate with solutions like DynamoDB, where we have, for example, you can archive data from DynamoDB onto S3 using Amazon Elastic MapReduce. It's a very simple operation. If you have data in S3, like clickstream data, and you want to pre-process it and push some of that data to DynamoDB so you can drive your applications using DynamoDB, you can do that as well with Amazon Elastic MapReduce really easily. If, for example, you have a bunch of DynamoDB tables and you want to query them, doing joins, group bys, etc., you can do that using Amazon Elastic MapReduce as a query engine. But you don't have to stop there. If you have, for example, some data in the DynamoDB that you want to query and some data in RDS, you can do that through Elastic MapReduce, tying all those components together. So once you run those clusters, you don't have to, as I mentioned earlier, invest in your operations team. You don't have to have an operations team because we integrate with the fabric of AWS to provide you monitoring and alarming so you can troubleshoot and understand what is going on with your jobs. By integrating with CloudWatch Metrics and alarms, we can provide you visibility of how your job is doing, how fast it's running, if there are any problems with it. And so you have about 23 or so metrics that just tell you the health of your cluster. So the key here is to try to make it super easy to use so that you don't have to invest in the operational support systems. So that's how we analyze the data sets. Now, let's talk about sharing. So when you share the data, you visualize it, you explore it, you decide what to do based on your analysis. And there's a few tools that we have, and there's a few partners that we partner with. So for example, let's take a look at this. One of our customers, Foursquare, has built this visualization of customer signups from 2008 to 2009 to 2011. And this visualization helps you understand how those sign-ups happen over time and in which region. You can create very similar visualizations with packages like gplot or R that are available natively in Amazon Elastic MapReduce clusters. By looking at this visualization is LinkedIn, and it helps you understand where your connections are coming from and makes your LinkedIn data come to life, right? From really, really long lists with multiple pages, now you actually start understanding your network. So really, really interesting, novel way of looking at the data. And EMR also integrates with tools like MicroStrategy Business Intelligence Platform so that you can build your visualizations directly from EMR by passing in the middle components and drive interesting presentations and slicing and dicing of the data directly from EMR. So I hope that this presentation helped you understand how to collect, store, analyze, and share data using Amazon Web Services. And I have a few minutes to take a couple of questions if you have any. Please. Mahout? It's a great question. Are there any plans including Mahout statistical package into EMR? In fact, Mahout statistical package is already included in EMR. You can use it right now, and there are a bunch of tutorials on our websites that can describe how to use Mahout. And it's a really powerful and easy-to-use tool that is native. Any other questions? Yeah, back there?
Is this integrated with the cloud search?
So it's integrated in the sense that you can take data generated by Amazon Elastic MapReduce and then ship it off to Cloud Search for indexing. Does it make sense? All right. Other question?
Do you have any solutions for changing non-structured data into structured data for big data projects?
Yeah, it's a great question. In fact, a lot of our customers are doing just that. They're taking maybe unstructured log stream, right? So access log data, and then they extract information out of it and try to structurize it. So this customer A looked at this property 50 times, and they create a table like that, and maybe then use what they call extract, transform, load, and ETL that table into a relational database like RDS, or even into DynamoDB, for example. So that work is possible today. And it's actually not a complicated task. In fact, we have tutorials on our website that talks about exactly that. How do you structurize data out of your unstructured data? So it's possible. Any other questions? All right. Thank you very much.